The problem that my group is trying to tackle is the nitrous oxide concentrations in the atmosphere. So pretty much, you might know nitrous oxide as laughing gas at the dentist, but when it comes to the atmosphere, it's no laughing matter. What's happening is this nitrous oxide is being produced from agriculture because the nitrogen fertilizers that are crucial are leaking this nitrous oxide, which is deteriorating the ozone. And this is bad because the ozone protects us from UV radiation and it's eroding the sun shield, which increases the risk of like health things like skin cancer and stuff like that. And by the end of the century, we'll have 4% less ozone as a result of nitrous oxide. So this really affects everyone because obviously we need these nitrogen fertilizers to produce our crops, but not if the nitrous oxide is killing our ozone layer.
Nitrous oxide is a secondary source because it is emitted after reacting with other things in the environment, and it has been becoming more and more of a problem since the Industrial Revolution. Agriculture accounts for 67% of all nitrous oxide emissions and creates 4.5 million tons of nitrous oxide per year. Nitrous oxide is also 300 times more powerful at warming the planet than carbon dioxide and methane, so it poses a very large threat.
We think a solution of nitrous oxide pollution could be the use of nitrogen-fixing rhizobium in place of nitrogen fertilizers. In order to test this solution, we'll create 3 greenhouse-like structures that will be vacuum sealed to contain all gases that the plants release. These greenhouses will grow corn, and in the first one will be a control, and we'll use no fertilizer or bacteria. The second will use nitrogen fertilizer, and the third will use rhizobium, which again is a nitrogen-fixing bacteria. These solutions will be used to test the independent variables of the nitrous oxide emission levels, as well as the plant mass that grows over a 100-day period. Our dependent variable will be the type of fertilizer or bacteria used. We will control things like sunlight, water, food, and soil that the plants grow in, to limit the amount of variables that could contribute to the nitrous oxide emission levels or to the mass of the plants. We believe that the rhizobium greenhouse would have the lowest nitrous oxide levels, and it wouldn't have a huge effect on the amount of plant mass that grows over the 100-day period. A successful experiment would show less nitrous oxide emissions and no reduction in the amount of plant matter that is grown without the use of fertilizers. And a failure would be if we lose a significant amount of plant mass or if nitrous oxide emissions remain the same or increase.
To switch to bacteria-type fertilizers, it would take about $70 million to have the operation fully started. We have a rough timeline for how long it would take for this operation to work. It would take about 10 to 15 years for the world to start using bacterial-type fertilizers. But we will need help to get the idea out there so that the world can know about it. So the EPA has started to get involved in the idea, and also some billionaires have started to invest in this.
And in conclusion to our clean air solution, we are looking forward to all of your support to our cause and a clean future for us all.